The nominated test is a maximal strength test, specifically a 1 rep max squat test. As this video plays through, you'll see a general warm-up, an athlete's self-selected warm-up, and a specific warm-up before the first trial is completed. These will all be explained in greater detail throughout the video. Given it is a 1 rep max test, it is a valid measure of maximal lower body strength. Had greater repetitions been completed requiring a regression calculation to provide a 1RM estimate, the validity of the test would have dropped significantly. However, given the increase in loads imposed upon the athlete when performing a 1RM, as opposed to say a 5RM, it is imperative that the athletes should be well conditioned to heavy weightlifting prior to the test being conducted. There are many studies, some referenced at the end of this film, that display the positive effect 1RM testing has on sports performance. This includes strong correlations to increases in vertical jump height and sprint speed, as well as the ability to differentiate elite and sub-elite playing levels. The reliability of the 1RM squat test is very high. The correlation coefficient is listed as 0.97 or nearly perfect by Hopkins classification system and has a coefficient of variation of 3.5% as listed in Physiological Tests for Elite Athletes, 2nd edition. This is in line with the typical error of 5 kilograms listed in the same publication using data from senior elite AFL players. Pre-test procedures for the athlete were as follows. Weigh-in at the venue was completed immediately prior to warm-up, wearing shoes and the same clothes that would be used in the squat test. The athlete weighed in at 100 kilograms. The athlete completed a questionnaire as seen here, inquiring about the consumption or taking of alcohol, caffeine, or nicotine, creatine, medications, or any unidentified health concerns. The athlete answered no to all of these questions. While suggested by the NSSQA, a food journal was not required by the athlete, but they were told prior to maintain their standard diet leading into the test. Similarly, they were told not to undertake any new exercise regimes in the days leading into the trial, and their resistance training volume was tapered down by 50%. The test incorporated a standardized warm-up procedure as recognized and suggested by the NSQA. 6 minutes of cycling was completed before a self-selected dynamic warm-up routine that the athlete completed individually. The self-selected routine included lunges, a squat stretch series, calf pumps, quadruped rockbacks, dynamic supine leg swings, and dynamic standing leg swings. Following this, a specific warm-up was also completed inside the squat rack. The athlete opted to complete 8 repetitions with 20 kg bar, and then 6 repetitions with 60 kg before increasing the weight to the recommended specifications for the listed specific warm-up. During the warm-up attempts, the athlete was given feedback on squat depth and validity of repetition. 8 repetitions were then completed with 75 kilograms, which is 50% of the specified 1 rep max of 150 kilograms, 2 repetitions below the permitted maximum. The athlete then rested 2.5 minutes, which is greater than the minimum 2-minute requirement, following which 4 repetitions were completed with 105 kilograms, being 70% of the 1 rep max specified at 150 kilograms. This was 1 repetition below the maximum permitted. The athlete rested for 3 minutes, greater than the 2 minutes required. At this point, a 1 repetition was completed with 135 kilograms, listed at 90% of the specified 1 rep max of 150 kilograms, and again 2 repetitions below the maximum permitted. 6 minutes rest was taken between the 90% warm-up trial at 135 kilograms and trial 1 at 150 kilograms. This was greater than the minimum required 5 minutes rest. On the first trial, 150 kilograms was successfully lifted on the first attempt. The athlete opted not to attempt higher and was happy that the result was a maximal effort. The NSSQA lists the requirement for successful completion of a 1RM squat as the following. A valid repetition is one in which the weight is lowered to the required depth and then extended to full leg extension with trunk as upright as possible. Technical violations which result in the trial being invalid and a second trial at the same weight provided excessive forward or sideways movement during the test, loss of controlled spinal position, lifting heels off the floor, not lowering to the required depth, raising of hips prior to shoulder elevation, or having greater than 2 seconds rest between repetitions. The required depth by the NSQA is for the crease of the hips to be level with the top of the knee. The NSSQA recommends that the assessor stands side-on to assess posture and hip-knee angle. In this assessment, the attempts were filmed from the suggested side position to allow review of the tests and a clear determination of successful or unsuccessful trials. This also allows technique assessment for future program design, providing valuable information to athletes and coaches. To assist with this procedure, bright tape was placed on the inferior portion of the femoral head. This allowed another view of squat depth. Bright marking tape was also placed on the end of the barbell. Since the tests were being filmed, this allows for possible analysis of bar path using video analysis technology. This provides coaches further information for future strength program design specific to the tested athlete. The NSQA suggests using a spotter when appropriate. Unfortunately, in this case, that was not possible, but the athlete being tested was experienced with maximal strength testing and opted to not have a spotter. A weight belt was opted by the athlete to not be worn. This prevents him from wearing a weight belt in future tests. The safety blocks were set at the highest possible point without interfering with squat depth. Heel blocks were not used, although they can be if athletes' anatomical structures limit range of motion or prevent the exercise from being performed with correct technique. Use of heel blocks should be consistent between tests. The athlete assumed a natural stance with feet approximately shoulder width apart. The bar was held in a high bar position on the trapezius during the test. The hands were in a comfortable position close to the shoulders. During the lowering action, the knees travelled forward over the toes. The heels remained in contact with the floor at all times during the test. A complete list of the NSSQA regulations that were adhered to by this test can be found at the end of this video as Appendix 1. As seen earlier, from Physiological Tests for Elite Athletes 2nd edition, published averages from senior elite AFL players are found to be around 100 to 160 kilograms plus or minus 20 kilograms at the average. The tested athlete's score of 150 kilograms places him at the high end of this average. The table also mentions a body weight ratio of 1.2 to 1.7 kilograms per kilogram body mass. The tested athlete weighed in at 100 kilograms pre-test, giving him a ratio of 1.5 kilograms per kilogram body mass, also within the population average. Viable alternatives to the 1RM squat include the isometric mid-thigh pull, which may prove easier to teach, record data from, and be safer, especially for novice athletes and weightlifters. The downside is the cost and transportation limitations of the required equipment. There has been a recent influx of research supporting the correlations between peak force displayed in the isometric mid-thigh pull and dynamic performance. These tests have high reproducibility given the ease at which they can be administered and reproduced. As mentioned, the squat can be interpreted as an absolute score, total weight lifted, or relative score, total weight divided by the athlete's body weight. Both have their practical applications, although many argue the relative strength is more relevant for athletes given their requirement for body control in a dynamic, reactive environment. Dan Baker in High Performance Training for Sports suggests that 1RM testing be conducted every 6 to 12 weeks. However, he also emphasizes the importance of the athletes pushing themselves to maximal effort repetitions or near maximal effort repetitions every week in order to continually build strength and accustom their bodies to handling great loads. Formal maximal strength testing should be undertaken no more frequently than at 6-week intervals. Novice athletes new to weightlifting will progress in their weight so quickly that testing dates are less important, whereas more experienced athletes will progress much more slowly and testing dates should be spaced far enough apart to see significant changes. Consideration should also be given to the time of the season and what the test results will be used for, i.e. cost versus benefit.